Uranosaurus. Uranosaurus was a relatively large herbivorous dinosaur discovered in North Africa, dating back to the early Cretaceous period. It measured about 7 meters long and is notable for its distinctive sail-like structure formed by elongated neural spines along its back. This sail could have been used for thermoregulation or display purposes. Uranosaurus exhibited features similar to both iguanodonts and theropods, indicating it might have been capable of both bipedal and quadrupedal movement. Its robust limbs and wide hips suggest it was well adapted for life in semi-arid environments. Camptosaurus. Camptosaurus was a genus of herbivorous dinosaurs that lived during the late Jurassic period. Characterized by its bipedal stance and robust build, it measured approximately 5 to 7 meters in length. Camptosaurus had a relatively long tail and a distinctively broad snout, which housed a set of grinding teeth adapted for processing tough vegetation. Its limbs were sturdy, allowing for both bipedal and quadrupedal locomotion. Notably, this dinosaur had a unique feature of elongated thumb spikes, likely used for defense or foraging. Muttaburrasaurus. Muttaburrasaurus was an iguanodontian dinosaur that roamed Australia during the early Cretaceous period. This herbivore could reach lengths of around 7 to 9 meters. It had a distinctive elongated skull with a flat, shovel-shaped snout, which is believed to have been adapted for cropping vegetation effectively. The structure of its limbs suggests it was primarily bipedal but capable of moving on all fours when necessary. Muttaburrasaurus is significant not only as an Australian representative of iguanodonts, but also because it provides insight into the evolution of ornithopods in isolated ecosystems. Centaursaurus, often referred to as the unicorn of the Cretaceous period, Centaursaurus is notable for its single, elongated nasal crest that resembles a horn. This unique feature suggests that it may have been used in mating displays or species recognition. Centaursaurus was a hadrosaurid dinosaur found in what is now China and lived during the late Cretaceous period. Its diet consisted mainly of vegetation, supported by its specialized teeth designed for grinding plant material. The discovery of this dinosaur has sparked discussions regarding crest evolution among hadrosaurs. Fukuisaurus. Fukuisaurus is a lesser-known dinosaur from Japan that belonged to the iguanodontian group. It is characterized by its relatively small size compared to other members of this group and features such as elongated limbs and distinctively shaped teeth adapted for herbivory. The discovery of Fukuisaurus has provided insights into the diversity of iguanodontians in Asia during the early Cretaceous period. Its fossils suggest it inhabited forested environments where it likely fed on low-growing plants. Brachylophosaurus. Brachylophosaurus was a herbivorous dinosaur belonging to the hadrosaur family, also known as duck-billed dinosaurs. It is characterized by its broad, flat head and distinctive crest on top, which likely played a role in communication or display. Fossils indicate that it had a robust body and strong limbs, suggesting it was well adapted for both grazing and moving quickly in herds for protection against predators. Brachylophosaurus lived during the late Cretaceous period and is notable for evidence of advanced social behavior, as indicated by fossilized trackways showing groups moving together. Iguanodon. Iguanodon is one of the earliest discovered dinosaurs recognized for its distinctive thumb structure. The most notable feature is its fifth finger, which evolved into a sharp spike, an adaptation that likely served as a defensive mechanism against predators. Iguanodon was a herbivore, characterized by a robust body and a beak-like mouth suitable for stripping leaves from plants. Fossils indicate it could grow up to 10 meters long and weighed about 3 to 4 tons. Iguanodon is significant not only for its unique anatomy, but also for being one of the first dinosaur fossils ever found, providing critical insights into early dinosaur evolution. Edmontosaurus. Edmontosaurus was another member of the hadrosaur family, notable for its duckbill-shaped mouth that allowed it to efficiently graze on low-lying plants. Living during the late Cretaceous period, this dinosaur could grow up to 13 meters long and possessed a dental battery containing as many as 1,000 tiny teeth at any given time. This adaptation enabled it to process tough plant material effectively. Edmontosaurus was often found in herds, suggesting social behavior that may have provided advantages against predators. Corythosaurus. Corythosaurus is known for its striking cranial crest, which resembles a helmet and may have been used for communication or display purposes among individuals. This dinosaur belonged to the hadrosaur family and was primarily herbivorous, feeding on soft vegetation. It could reach lengths of approximately 9 meters and had a relatively flat skull, with a large nasal passage running through its crest. The distinctive shape of its crest likely played a role in producing vocalizations, which would have been essential for social interaction within herds. Maiasaura. Maiasaura is often referred to as the Good Mother due to evidence suggesting that it exhibited parental care behaviors. This duck-billed dinosaur lived in herds during the late Cretaceous period and is particularly noted for nesting sites containing eggs and juvenile fossils. It had a broad snout suited for herbivorous feeding and could reach lengths of about 9 meters. The discovery of well-preserved nests indicates that Maiasaura parents likely protected their young from predators and provided care during early development stages. Anatotitan. Anatotitan is considered a species of hadrosaurid, commonly known as duck-billed dinosaurs. It lived during the late Cretaceous period in what is now North America. Anatotitan was characterized by its elongated skull with a broad, flat snout resembling that of a duck, which suggests it had a diverse diet consisting mainly of aquatic plants and soft vegetation. The dinosaur could grow up to about 9 meters in length and was known for its social behavior, often found in large herds, which provided safety in numbers against predators. Olorotitan. Olorotitan is another hadrosaurid from the late Cretaceous period found in Asia. It lived around 72 million years ago and is known for its impressive crest on its head, which may have been used for communication or display purposes within species. Olorotitan could grow up to approximately 8 meters long and exhibited features similar to other hadrosaurs, such as elongated limbs and a flexible neck that allowed it to reach high vegetation. The discovery of Olorotitan adds valuable information about the diversity and evolutionary adaptations of hadrosaurs during this era. Shantungosaurus. Shantungosaurus is another member of the hadrosaur family and is recognized as one of the largest known duck-billed dinosaurs. It lived during the late Cretaceous period in what is now China. Shantungosaurus could reach lengths of over 15 meters, making it one of the largest ornithopods. Its distinctive features included a large crest on its head and complex dental batteries that allowed it to process tough plant material efficiently. The size and structure of Shantungosaurus suggest that it was well adapted to life in various environments, ranging from floodplains to forests. Altorhinus. Altorhinus is a lesser-known genus of hadrosaurid dinosaur that lived during the early Cretaceous period, approximately 125 million years ago. It was characterized by its unusually high nasal ridge and elongated snout, which might have facilitated feeding on aquatic vegetation. Fossils were discovered in Mongolia, indicating it inhabited lush environments near rivers or lakes. Altorhinus was relatively small compared to other hadrosaurs, measuring about 6 meters in length. Its unique cranial features suggest adaptations for specific feeding strategies or social interactions. Tyrannosaurus. Tyrannosaurus is a genus of hadrosaurid dinosaur from the late Cretaceous period, known primarily from fossil evidence found in China. This dinosaur is notable for its large and complex cranial crest that suggests it had advanced communication abilities similar to those hypothesized for Lambeosaurus. Tyrannosaurus could reach lengths of up to 8 meters. Its fossils indicate it lived in a semi-aquatic environment where it likely fed on abundant vegetation along riverbanks and floodplains. Prosaurolophus. Prosaurolophus is a genus of hadrosaurid dinosaur that lived during the late Cretaceous period, approximately 75 to 74 million years ago. It is known for its distinctive elongated cranial crest, which was likely used for display and possibly vocalization. The crest's shape varied among species, with Prosaurolophus featuring a backward-sweeping crest. This herbivorous dinosaur could grow up to 8 meters long and was characterized by a robust body and a duckbill-shaped snout ideal for browsing on vegetation. Its fossils have primarily been found in North America, providing insights into the diversity of hadrosaurs during this era. Lanzhusaurus is a more recently discovered genus of hadrosaurid dinosaur from the early Cretaceous period in what is now China. It is distinguished by its robust body and relatively short limbs compared to other hadrosaurs. The cranial structure indicates it possessed some form of head ornamentation similar to its relatives, but less pronounced than those of Lambeosaurus or Tyrannosaurus. Lanzhusaurus likely inhabited floodplain ecosystems where it grazed on various plant materials. Its discovery has provided valuable insights into the evolutionary adaptations of hadrosaurs in Asian regions during the late Cretaceous. Lambeosaurus is another member of the hadrosaur family and is recognized for its prominent head crest, which varies significantly among individuals. The hypothesis that this crest may have functioned like a trumpet is intriguing. It suggests that Lambeosaurus could communicate with one another over long distances or signal alarm when predators like Tyrannosaurus rex were nearby. Lambeosaurus lived around 75 million years ago in what is now Canada and could reach lengths of about 9 meters. Its diet consisted primarily of low-lying plants, and its unique skull structure suggests advanced social behaviors among herds. Saurolophus is a genus of hadrosaurid dinosaur that lived during the late Cretaceous period, approximately 70 to 66 million years ago. This herbivorous dinosaur is particularly noted for its distinctive long, backward-curving crest on its head. The crest could reach lengths of up to 2 feet and may have been used for display purposes or possibly for sound production. Fossil evidence suggests that Saurolophus was a social animal that lived in herds, using its crest not only for communication but also as a visual signal to attract mates or establish dominance within groups. Parasaurolophus is another hadrosaurid known for its impressive cranial crest that can measure over 3 feet in length. This crest is often described as resembling a trumpet or horn and likely served multiple functions. It could have been used in vocalizations to communicate with others in the herd or to warn of predators. The structure of the crest indicates that it was hollow, which may have amplified sounds produced by the dinosaur. Additionally, its long limbs and robust body suggest that Parasaurolophus was well adapted for a herbivorous diet, feeding on a variety of vegetation found in its environment. Lambeosaurus magnicristatus is characterized by an exceptionally large and complex cranial crest compared to other members of its genus. The unique morphology of this crest suggests advanced capabilities for sound production and social interaction among individuals. As with other Lambeosaurines, it is hypothesized that the crest played a crucial role in communication during mating displays or alarm calls in response to predators such as Tyrannosaurus rex. The discovery of this species has provided valuable insights into the diversity and evolutionary adaptations of hadrosaurs.